Our last section is on projectile motion. So many objects that are shot through the air, and these are called projectiles, follow the path of a parabola. So this is really why it's in this section, because the parabola is the graph of a quadratic function. So we have a formula here where h is the height of the object in feet, v0 is the initial velocity, and t is the time in seconds. Now on these problems we are going to be having to use the intersection command, so that's why this is here. Okay, 16 says an arrow is shot upward at a rate of 250 feet per second. Use the projectile formula to determine when the height of the arrow will be 300 feet, and then round your answer to the nearest tenth. So we have a special window here that they want us to use. Okay, so I need to have two functions here. My y1 is going to be negative 16x squared plus, now I'm not going to put v0. So they actually need to tell us what v0 is. So what is my initial velocity? That will be the 250 feet. So this is plus 250 times x. So I am using this formula, but I'm using x instead of t, and I actually know what v0 is. It's 250 for this problem. And then my y2, I want to be what the height is that I'm looking for. So they're asking when is it going to be 300 feet, so I'm going to set my y2 equal to 300. Okay, so if you type these into the y equals command, and then go to the window and type in those values that they wanted you to for the window, and then press graph, this is what our graph looks like. So the arrow goes up, and it's going to hit 300 there, and then it's going to come back down, and it hits 300 there. So it hits it twice, once on the way up and once on the way down. And we need to find both of those. So I'm going to go to second calc and do intersection, and I need to declare both curves. So sometimes you need to press left and right so you can actually see the cursor to see which curve that you're on. It does tell you up here which curve you're on as well. So we're on the y1, and I can see my cursor here, and if you press enter, then it locks that in as the first curve. So the parabola is locked in as the first curve. Then you want to select the line, so you can kind of see it there, the line as my second curve, and press enter. And then we need to make a guess. So I'm going to try and figure out what this point is first, so I want my guess to be closer to that point. And then press enter, and that is my intersection. So it's really just the x value that we want, and they wanted us to round to the nearest tenth. So this would be 14.3. Okay, let's get the other intersection point. So go back to second calc and then do intersect, and select the parabola as your first curve and press enter. Select the line as your second curve and press enter. And then make a guess that's closer to the point on the left, because we already have the point on the right. And press enter. And they want us to round this to the nearest tenth. So this is 1.3. Okay, so let's go back to the problem. So this is going to be at 1.3 seconds and 14.3 seconds.